Hello, this video is going to be for Monday, November 11th, 2019. Talking a little bit quietly because my daughter is sleeping on a couch right in front of me and she's a little bit under the weather, so I don't want to wake her up. I also don't want to leave the room because then she gets scared if she doesn't see me right away when she wakes up and she's sick. So here I am. Our objective today is to be able to define a linear system of equations, a non-linear system of equations, be able to solve one and be able to solve one with substitution. So let's go and get going on this. Now, if you're new to taking notes from a video, maybe you're not, but if you are, make sure you have a separate sheet of paper and pencil and calculator out. And so not only paper, but also a pencil and a calculator. And maybe your headphones, so you're not interrupting other people. Headphones. Phones. Pause the video if you'd like, because you can do that on the video, or rewind it if you need to rewatch something. And some students even watch the entire video once and then take notes when they watch it a second time. It's totally up to you. I'm going to keep this video under 15 minutes, so I'm going to go and get going. And again, if I'm going too fast, please pause the video. Okay, we're going to just do a couple warm-up problems. These are not in your student journal. They're just going to be here. We're going to solve 1 and 2 using a graphing calculator. Before I do that, I just want to do something here. Let's go and just do that. Copy again, copy and paste. Okay, I'm just going to put that here. Okay, so I'm going to solve these two problems. Not by using a graphing calculator, because I don't want that to be the focus. I just wanted to do using a graph. So, first of all, a system is two or more equations. And I'll put that on the next slide. But a system is two or more equations that are graphed in the same graph. And if you graph two or more equations in the same graph, sometimes those equations will overlap, sometimes they won't. If they overlap, where their intersection is the solution. And again, I'll summarize all that on the next slide. Let's graph this first one. X minus 4y equals 9. And 2x minus 3y equals 11. So this is for number 1. Let's just draw a line here. Okay, x minus 4y equals 9. I can put this in slope-intercept form, and this might be a blast from the past, where I can just subtract x and subtract x from both sides. I get negative 4y equals negative x plus 9. And then I can divide everything by negative 4, every single thing. And what I end up getting is I get y is equal to, and this is again just for the first equation, 1/4 x minus, because a plus and a minus make a minus, 9 over 4. If you want, you can do 1/4 x minus 2.25, because that's what 9 over 4 is. And let's graph that. Again, this is for equation 1. Negative 2.25 is going to be about right here. Okay, there we go. That's better. And as my slope is up 1, so I have to go up 1, and then to the right 4. So up 1 and to the right 4. 1, 2, 3, 4. This is going to be hard because I don't have my pen on me. And I can keep doing that each time. Up 1, over 4. 4, okay. And I can connect those points and make a line. And that's going to be my first one. Let's go ahead and do blue. Okay, so you can see, kind of horrible at this, even with the computer. So let's not judge. Okay, so this is my first line approximately. Let's do the second line in red and do the same exact thing as before. So 2x minus 3y equals 11. Okay, let's solve for x. So let's subtract the 2x on both sides. And remember, 11 minus 2x is 9x. It's just going to be negative 2x plus 11 equals the negative 3y. And when you divide by negative 3 on both sides, everything by negative 3, I get y is equal to 2/3 x minus 11 over 3. If I want to rewrite that, that's fine. 2/3 x minus 3.6. Repeating. Okay, so now I'm going to be at negative 3.6, and I'll do this in red. So we're going right there. And then I have to go up 2 and over 3. Up 2, over 3. From my red point. So up 1, 2, over 1, 2, 3. So somewhere around right here. And if I keep doing that, I'll be able to get points, but I only need 2 points to make a line, so let's just make the line. Mr. Lake can just make the line and move on. Alright, so it looks like I'm going to be about right here. What I can see is that those two lines intersected, which is exactly what I want. And where they intersect is going to be my solution to the problem. So this point right here, wherever that is, solution to the problem, we can approximate it for now. Let's say that that solution is about, oh god, this is horrible. It looks like it's about 2.5, comma 3.5, negative 2.5, here. Let's say that it's about at 2.5, comma, negative 2. That's an approximation. That may not be exact. Let's use Desmos to see where exactly it is. You don't have to do that on your computer. You can just watch. And then I'm going to move on. Let's do x minus 4y equals 9. Okay, so that's that graph. That's the 2x minus 3y equals 11. Okay, and they intersected about, oh, I was really off, 3.4 comma negative 1.4. So the real answer is 3.4 comma negative 1.4. One thing that you can notice right away is a disadvantage that you have to having to solve this by just a graph. You kind of get inaccurate answers. Okay, let's do y equals 2x. Y equals 2x has no y-intercept. Oh, I didn't write down my other... No, I did. This is the answer for number 1. For number 2, let's graph y equals 2x first. I'll do that in blue. There is no y-intercept, and the slope is 2, so let's go up 2 and over 1, and up 2 and over 1 again. And let's connect those points. Look at that, Mr. Lakin. That looks really good. That looks even better. Okay, so that's my first line. Now let's go and do y equals 3x plus 5y equals 0. Sorry, 3x plus 5y equals 0. If I move that 3x over, then it's a negative. So I move the 3x over on the other side. I'm going to divide by 5 on both sides. I get y equals negative 3 over 5x. So this means I'm going to go down 3 and over 5, 1, 2, 3, 4, 5, from the origin. And I can see already where the two lines intersect, so this one was an easier one. They both intersect at 0, 0. And again, Mr. Lakin has a horrible attempt at using your computer to make a line. Should probably retire at an early age. Okay, so my answer is going to be 0, 0. I can check that on Desmos. X and 3x plus 5y equals 0. Okay, so indeed those two intersect at 0, 0. I think in class on Thursday I'll show you how to find these intersections on a calculator if you're interested in doing that. Let's go on to the next ones. So that was your warm-up. What is a nonlinear system of equations? Okay, so a system of equations, as I said before, is going to be, let's just do this, and this. Okay, a system of equations is going to be two or more equations plotted on the same graph. That's what a system of equations is. Okay? A nonlinear system of equations. So nonlinear means that It's just not always lines. What could it be then? Parabolas? Trig functions? I mean, it could be anything, but really for our purposes, it's just going to be parabolas. It'll be a parabola intersecting a line. So that's what those two things mean. Let's just put a little arrow here. Okay. And we're going to work on solving those in the next 4 minutes. So let's go and keep going. So let's solve this problem, equation 1 and equation 2. What I would recommend is pausing the video and trying the problem on your own first before you see the answer. So please pause the video now so that way you can go and see if you can do the problem. Hopefully you had this stuff. In the green, I have b equals -1 and m equals -2 for the second equation, which means my slope is going down 2 and to the right 1 each time. My y-intercept is -1, and that green line is plotted here. Again, intercept at the y-intercept at -1, and then going down 2 over 1 each time. For my red took a little bit of work, and what I did to graph that, I could have done 1, made a table, or 2, completed the square to get the thing in vertex form, and solved it. If you didn't want to do completing the square, other options could have been finding your vertex with b over 2a, and then plugging b over 2a to get your y value. I mean, there's a lot of routes you could have gone. I would have relied on that cheat sheet that you had for that. Okay, so if you got it in vertex form, if you found your vertex should have been 1, -2. So when you plot 1, -2 is down here, and the parabolas go up 1 over 1 in both directions, and then up 4 over 9 in both directions. And what that gives us is it gives us an intersection point right here of 0, -1. So our answer to the question is 0, -1. Now I could check that by plugging 0 into x in both equations. So if I plug 0 in here and here, I end up getting a -1 out. And if I plug in 0 for x in the second equation, I end up getting -1 out. 0, -1 is my answer. Okay, now this one. I don't know if you remember this, but ways that you could solve a system equation are going to be by graphing, by substitution, and by elimination. And you can do that for any system, whether it's a linear system of equation, whether it's a nonlinear system of equations. Those 3 methods will generally always work. So let's do this one. I notice that they're both equal to y. Because they're both equal to y, what I can do is set them equal to one another. So -4x plus 8. Well, I've done this before. This is a quadratic equation, and I can actually move everything to one side of the equation to solve for x. I'm moving the x squared because I usually like my x squareds positive. So I'm going to get, okay, so these cancel. 0 equals x squared minus 4x plus 4. Okay, I could try the Foster method here for those of us that know us. Something times something equals something, and something plus something equals something. And if this doesn't work, so this is option 1, if option 1 fails, quadratic formula. That x equals opposite b, etc. It looks like -2 and -2 work, though. So this is going to be factored as 0 equals x minus 2 times x minus 2. And when I set this equal to 0, when I said x minus 2 equals 0, because that's what I do, I said x minus 2 equals 0, then I saw x equals 2. But then I still have to get the y value. So the y value could be plugged into either of these equations. So when x equals 2, I get -2 squared plus 4, which is equal to 0. I get -4 times 2 plus 8, which is equal to 0. So my y value is 0. So the answer to the question is 2, 0. That's it, guys. Thanks for watching.